Quarter 2, Test 1 review. We're working on sections 3.7 and 3.8. So we look at example 1. We're told to state if the binomial is a factor of the polynomial. So we want to first solve for x. We're going to start with the x plus 3, set it equal to 0. We're going to have to subtract 3 from each side. We get that x is equal to negative 3. We're going to use synthetic division. The negative 3 goes in our box. We're going to have a 1, a 2, a 0 because there's no x, and then the negative 5. We're going to bring down that 1. We're going to have negative 3 times 1 is negative 3. Subtract that with the 2. We're left with a negative 1. Negative 1 times 3 is 3. Add that with the 0. We get 3. 3 times negative 3 is negative 9. And negative 5 times negative 5 plus negative 9 is negative 14. So because our remainder is not 0, that x plus 3 is not a factor. For 2, we have x minus 1. We want to set that equal to 0. Solve for x. We're going to add the 1 to both sides. We get x is equal to 1. We're going to use our synthetic division. Put the 1 in our box. We're going to have a 4, a 0, because we don't have an x cubed, a negative 5, a 3, and a negative 2. So that 4 gets dropped down. 4 times 1 is 4. Add that with the 0, it's 4. 4 times 1, again, is 4. Add that with the negative 5, we get a negative 1. Negative 1 times 1 is negative 1. Add that with a 3, we get a positive 2. 2 times 1 is 2. Add that with the negative 2, we get a 0. Because our remainder is 0, that x minus 1 is a factor. For 3, we have 2x plus 6, so 2x plus 6 is equal to 0. Subtract the 6 from each side. We get 2x is equal to negative 6, and then divide by 2 from each side. We get x is equal to negative 3. Use that with your synthetic division. The negative 3 goes into the box. We're going to have 1, 1, negative 14, negative 24. We're going to bring down that 1. 1 times negative 3 is negative 3. 1 minus 3 is negative 2. Negative 2 times negative 3 is a positive 6. Negative 14 plus 6 is a negative 8. Negative 8 times negative 3 is a positive 24. Add that with the negative 24, we get 0. So because our remainder is 0, that 2x plus 6 is a factor. If we look at our next example 4, we have to factor completely. So we have 3x squared minus 13x minus 10. We can't factor anything out, so we're going to do 3 times negative 10. That gives us the negative 30. We're going to find the factors of negative 30 that add up to be a negative 13. It's going to be a negative 15 and a positive 2. So this is going to be 3x squared minus 15x plus 2x minus 10. So factor by grouping. The 3x is going to be pulled out of the first, and the 2 is going to be pulled out of the second. So it's going to be 3x times x minus 5 plus 2 times x minus 5. Our two parentheses are the same, so we're going to form one with a 3x and the positive 2, and then write the x minus 5 one more time. For 5, we have 15x squared minus x plus 6. So 15 times negative 6 gives us a negative 90. So negative 90, the factors are a negative 10 and a positive 9. So we're going to replace that with the negative x. So we're going to have 15x squared minus 10x plus 9x minus 6. Factor by grouping. Factor out the 5x from the first set and factor out the 3 from the second. So we're going to have 5x times 3x minus 2 and the 3 times 3x minus 2. Once again, those parentheses are the same, so rewrite 1 and make another set with the 5x and the positive 3. So we have 3x minus 2 times 5x plus 3. For 6, we have x squared plus 16x plus 63. We are going to factor this by finding the factors of 63 that add up to be a positive 16. So we have 9 and 7 that add to be a 16. So this is going to be x plus 9 times x plus 7. For 7, we have 10x squared minus 6x plus 15xy minus 9y. We have 4 terms, so we are going to factor by grouping. The first set, factor out a 2x. Second, factor out a 3y. So this is going to be 2x times 5x minus 3 and 3y times 5x minus 3. So then this gives us 2x plus 3y times 5x minus 3. For 8, we have 4x squared minus 16x plus 16. We're going to factor out our greatest common factor, which is that 4. So we're going to be left with 4 times x squared minus 4x plus 4. The factors of that 4 that add up to be a negative 4 or negative 2, negative 2. So this is going to be 4 times x minus 2 times x minus 2. We have 2 sets of the same parentheses, so we can rewrite it as 4 times x minus 2 raised to the second power. For 9, we have x cubed minus x squared minus 16x plus 16. Factor by grouping. Pull out an x squared from the first, pull out a negative 16 from the second. So it's going to be x squared times x minus 1 minus 16 times x squared, x minus 1. So then this is going to be x squared minus 16 times x minus 1. This is not being done factoring, so we can still factor the x squared minus 16 with a difference of squares. So we're going to have x minus 4 times x plus 4 times x minus 1. For number 10, we have 2x cubed minus 16x squared plus 32x. We can factor out a greatest common factor of 2x, so we'll do that first, giving us 2x times x squared minus 8x plus 16. The factors of 16 that give us a negative 8 are negative 4, negative 4. So this is going to factor out to be 2x times x minus 4 times x minus 4. Then we have the same set of parentheses twice. We can do 2x times x minus 4 raised to the second power. For 11, we have 64 plus 27y cubed. We can do a sum of cubes here. So we can do our a is the cube root of 64, which is 4. Our b is the cube root of 27y cubed, which is 3y. Because there is a positive between those two terms, we're going to use a plus b times a squared minus ab plus b squared. So this is going to be 4 plus 3y times 4 squared minus 4 times 3y plus 3y squared. So 4 plus 3y stays. We're going to multiply that by 16 minus 12y plus 9y squared. For 12, we now have a sum of cubes that we can first factor out the greatest common factor. Our greatest common factor is 3, so that's going to leave us with 3 times x cubed plus 27. Our a is the cube root of x cubed, which is x. Our b is the cube root of 27, which is 3. So we're going to use the sum of cubes and make sure we bring down that 3 to go in front. So a plus b times a squared minus ab plus b squared. Plug in, we're going to have 3 times x plus 3 times x squared minus x times 3 plus 3 squared. So simplify this. This is going to leave us with 3 times x plus 3 times x squared minus 3x plus 9. For 13, we have 4y to the 4th power minus 256y. So we're first going to start by dividing out a 4y, which is our greatest common factor. we're going to be left with y cubed minus 4 goes into 25 6 times with 1 left over. 4 goes into 16 4 times. So 64. We can now do a difference of cubes. Our a is going to be the cube root of y cubed, which is y. Our b is the cube root of 64, which is 4. Because we have a negative there between those two terms, we're going to bring the 4y down, multiply it by a minus b times a squared plus ab plus b squared. So plug in your values. You're going to have 4y times y minus 4 times y squared, y raised to the second power, plus y times 4 plus 4 raised to the second power. So this is going to be 4y times y minus 4 times y squared plus 4y plus 16. For 14 and 15, we are solving by factoring. So first, factor out your greatest common factor with 14, which is x. We're going to have x times x squared plus 18x plus 81 is equal to 0. Your factors of 81 that add up to be an 18 are 9 and 9. So this is going to be x times x plus 9 times x plus 9 is equal to 0. Set each part equal to 0, so x is equal to 0, x plus 9 is equal to 0, and x plus 9 is equal to 0. Subtract those 9s over. We get that x is equal to negative 9 for both. So our solutions are the x is equal to 0, x is equal to 9, and x is equal to 9. For 15, we have 4x cubed minus 8x squared minus x plus 2. We're going to factor by grouping. Since we have 4 terms, we're going to factor out a 4x squared and a negative 1 from both sets of parentheses. So we're going to have 4x squared times x minus 2, and negative 1 times x minus 2 is equal to 0. So this is going to give us 4x squared minus 1 times x minus 2 is equal to 0. We're going to factor out that 4x squared minus 1 because it's a difference of squares. So it's going to be 2x minus 1 times 2x plus 1 times x minus 2 is equal to 0. From here, set each part equal to 0 and solve for x. So 2x minus 1 is equal to 0. 2x plus 1 is equal to 0. And x minus 2 is equal to 0. With a 2x minus 1 is equal to 0, we're going to add 1 to both sides. To get 2x is equal to 1. Then we're going to divide by 2 on both sides to get x is equal to 1/2. With the 2x plus 1 is equal to 0, subtract 1 from both sides. 2x is equal to negative 1. Then divide each side by 2. X is equal to negative 1/2. For the x minus 2 is equal to 0, add 2 to both sides. You get x is equal to positive 2. So your solutions with this are the x is equal to 1/2, x is equal to negative 1/2, and x is equal to 2. For 16, we're identifying the roots of each equation and stating the multiplicity of each root. So for 16, we are moving that 27 over first by subtracting it from both sides. We're left with x cubed plus 3x squared minus 9x minus 27 is equal to 0. Factor by grouping because you have 4 terms. Pull out the x squared, pull out a negative 9. So it's going to be x squared times x plus 3 and negative 9 times x plus 3 is equal to 0. From here, you're going to have x squared minus 9 times x plus 3 is equal to 0. This x squared minus 9 factor completely. You're going to have x minus 3 times x plus 3. Keep the x plus 3 and set everything equal to 0 now. So you're going to have x minus 3. You're also going to have x plus 3 squared is equal to 0. Now you can factor. So when we rewrite it like this, it shows us what our multiplicity is starting off with. So that x minus 3 we can set equal to 0, and that x plus 3 we can set equal to 0, and only have to do that x plus 3 once because we see that that exponent of 2 is there, so our multiplicity is 2 for whatever our solution is for that. So we are going to add 3 to both sides to get x is equal to 3, and subtract 3 from both sides on this one to get x is equal to negative 3. So your roots are the 3 and the negative 3. Your multiplicity is of 1 at x is equal to 3, and of 2 at x is equal to negative 3. If we look at example 17, we have 4x to the 5th power minus 8x cubed plus 4x is equal to 0. So we're first going to start by factoring out a 4x. So 4x times x cubed, x to the 4th minus 2x squared plus 1 is equal to 0. You can factor this x to the 4th minus 2x squared plus 1 by doing 4x times x squared minus 1 times x squared minus 1 is equal to 0. Now you can factor these out as well to be 4x times x minus 1 times x plus 1 times x minus 1 times x plus 1, and set it all equal to 0. So now set each part equal to 0, or rewrite. If you rewrite, you'd have 4x times x minus 1 squared because it happens twice, and then x plus 1 squared because that happens twice as well. So rewrite 4x is equal to 0, x minus 1 is equal to 0, x plus 1 is equal to 0. Solve for x, divide by 4, you get x is equal to 0, add 1, you get x is equal to 1, subtract 1, x is equal to negative 1. So now state your multiplicity. These are your roots. Your multiplicity is of 1. Multiplicity of 1 at x is equal to 0. It's of 2 at x is equal to 1, and x is equal to negative 1. So these are also part of your answers. For 18, we have x to the 4th power minus 12x squared is equal to negative 36. Add the 36 over to both sides. We have x to the 4th power minus 12x squared plus 36 is equal to 0. From there, we're going to have x squared minus 6 times x squared minus 6 is equal to 0. You cannot factor these any further, so if you would like, you can write it as x squared minus 6 is equal, or squared is equal to 0. Solve for one of these, so x squared minus 6 is equal to 0. Remember that it's squared though. So when you solve these, you're going to add 6 to both sides. Then you have x squared is equal to 6. Take the square root of both sides. When you take the square root of your finding for x, you have to include the positive and the negative of that. You can't take the square root of 6, so you leave it plus or minus the square root of 6. Remember that you have a multiplicity of 2 at this. So this is your roots, the plus or minus 6, as well as a multiplicity of 2 at x is equal to positive or negative square root 6. For 19, we have 3x to the 5th power plus 42x to the 4th power plus 147x to the 3rd power, all equal to 0. So divide out that 3x to the 3rd power first. We're going to have 3x to the 3rd power times x squared plus 3 goes into 42 14 times. Keep the x. 3 goes into 14 4 times. 3 goes into 27 9 times. So that's a perfect square trinomial. So this is going to be 3x cubed times x plus 7 squared is equal to 0. So the 3x cubed is equal to 0, and the x plus 7 is equal to 0. So solve for each, divide by 3. X cubed is equal to 0. Cube root each side. X is still equal to 0. It kind of looks as not equal to, so x is equal, there we go. For the x plus 7 is equal to 0, subtract 7 from both sides, x is equal to negative 7. So our roots are the x is equal to 0 and the x is equal to negative 7, but our multiplicity is of 1 at x is equal to 0, and then it's of 2 at x is equal to negative 7 because we had that exponent of 2 there. If we look at our last question, that last question should have been equal to 0. So this is equal to 0 because we are solving for this. So if we're first going to factor out that 5, to give us 5 times x to the 4th power minus 625 is equal to 0. This is a difference of squares, so this is going to be 5 times x squared minus 25 times x squared plus 25 is equal to 0. We're going to keep factoring that x squared minus 25, so 5 times x minus 5 times x plus 5 times x squared plus 25 is equal to 0. From here, we are going to do 5 is equal to 0. Well, nope, that's not true. We can get rid of that one. X minus 5 is equal to 0, x plus 5 is equal to 0, and x squared plus 25 is equal to 0. Add the 5, we get x is equal to 5. Subtract the 5, we have x is equal to negative 5 as well. If we subtract the 25 from here, we're going to have x squared is equal to negative 25. If we take the square root of both sides, you cannot take the square root of that negative 25, so you cannot do it. That's not a real root. So your roots are only x is equal to negative 5 and positive 5. Your multiplicity is of 1 at x is equal to negative 5 and positive 5.